What if the Big Bang wasn't the beginning? You probably don't fully understand the Big Bang theory, and honestly, that's not your fault. The version most of us learned in school is outdated. I recently finished a physics degree, and even there, what we were taught doesn't quite match what many modern physicists actually believe. When I first started looking into the Big Bang, I wanted to explain what it was and why skeptics were wrong. But pretty quickly, I realized I was the one who had it wrong. Most scientists today don't see the Big Bang as the literal beginning of the universe. So, what really happened? What was it that banged in the first place? A singularity? Nothing? Something else? Let's break it down with an open mind. Since ancient times, people have looked at the sky and wondered how everything began. Different cultures had their own stories about gods creating worlds or endless cosmic cycles of birth and destruction. Then came Isaac Newton in 1687, who connected the motion of falling apples with the motion of planets. His theory of gravity worked beautifully, but it had a problem. If every bit of matter pulls on every other bit, shouldn't the whole universe collapse in on itself? To fix this, Newton imagined an infinite universe with no center, a perfect balance that kept everything from falling together. That became our first real model of the cosmos, the static universe, infinite in both space and time. But there was an issue. If the universe truly stretched on forever, then every direction you looked should eventually hit a star or galaxy. The night sky should be as bright as the Sunday. Clearly, it isn't. Something didn't add up. Fast forward to the early 1900s. Albert Einstein released his general theory of relativity, showing that space and time aren't separate. They're part of the same fabric. Gravity isn't a pulling force. It's the warping of that fabric by mass. When astronomers confirmed his theory in 1919, by watching starlight bend during a solar eclipse, Einstein became a global celebrity. But even his equations showed a problem. The universe couldn't stay static. It had to expand or collapse. To preserve the calm, eternal cosmos he believed in, Einstein added a cosmological constant, basically an energy of empty space, to keep things balanced. Later, he called it his biggest mistake, though modern physics might actually prove him right. Around that time, astronomers were trying to figure out mysterious patches of light in the night sky called nebulae. Were they clouds of gas or island universes? That mystery was solved thanks to Henrietta Swan Leavitt, a brilliant but underappreciated astronomer. She discovered a way to measure the distance to certain stars based on how they pulsed. Using her method, Edwin Hubble calculated that the Andromeda Nebula was nearly 1 million light-years away, far beyond the Milky Way. The universe had just gotten a lot bigger. Hubble then noticed something else. Galaxies farther away were moving away faster. The universe wasn't static after all. It was expanding. The steady universe of Newton and Einstein was officially dead. Physicists began to think backwards. If the universe is expanding now, it must have been smaller and denser in the past, maybe starting from a single, incredibly compact state. Georges Lemaître, a Belgian priest and physicist, called it the primal atom. Fred Hoyle, who didn't believe in it, mockingly called it the Big Bang. The name stuck. Scientists went on to calculate what that early universe would have been like. A super hot soup of particles. As it expanded and cooled, the first hydrogen and helium atoms formed. The leftover light from that era, now stretched into microwaves, became what we call the cosmic microwave background, or CMB. When astronomers finally detected it in 1965, it was the proof they needed. The Big Bang wasn't just a theory, it was real. By the 1,990 seconds, NASA's COBE satellite captured a detailed map of this ancient radiation. Stephen Hawking called it one of the greatest discoveries in science. But the Big Bang model still had problems, such as the horizon problem, the flatness problem, and the monopole problem. To solve these, physicist Alan Guth proposed the idea of cosmic inflation, a brief period right after the Big Bang, when the universe expanded faster than the speed of light. Inflation explained everything that didn't fit before. It made the universe flat, uniform, and smooth, and it even explained why galaxies exist. Tiny quantum ripples in the early universe were stretched by inflation and grew into the galaxies and clusters we see today. So what actually banged? According to the inflation theory, it wasn't matter exploding out of a single point. It was space itself. Empty space filled with a powerful field that suddenly expanded, converting its energy into matter and radiation. That expansion didn't happen everywhere at once either, which means there could be countless other bubbles of universe beyond ours. That's how the multiverse idea was born. This is now the leading explanation among cosmologists. But even this theory has open questions. Inflation works beautifully in math, but it's tough to test directly. And while it explains how the universe expanded, it still doesn't tell us why it began in the first place. So yes, the hot, dense Big Bang definitely happened. We can literally observe its leftover light. But what triggered it, and what came before, is still an open mystery. As physicist Alan Guth once said, the Big Bang theory was never really a theory of the bang. It explains what happened after, not why it happened at all.